Alright folks, in this video, which is a continuation of section 5.2, we're going to start to look at dividing radicals. And to do that, we're going to begin by looking at how you rationalize the denominator in a radical expression. When we looked at simplifying radicals, one of the things that was mentioned that we didn't really get into was that for a radical to be simplified, you can't have for a radical expression to be simplified, you can't leave a radical in the denominator. Okay, so as you can see with this one, 5 over 2 root 3, we have a radical in the denominator. If it's just a monomial square root denominator like this one, getting rid of that is actually fairly straightforward. All that we're going to do is scale the top and bottom by a number that will change this radical into a rational number. And in this case, that's just going to be the square root of 3. We're going to multiply top and bottom by the square root of 3. So when we do that, we take our 5 over 2 root 3, and we multiply top and bottom by the square root of 3. Alright, this is very much analogous to coming up with an equivalent fraction. So if I wanted an equivalent fraction to 2/3, for example, if I scaled this by, 4 over 4, I could come up with 2/3 is equivalent to 2 times 4 is 8, 3 times 4 is 12. So that would be 8/12. Right, so all that we're doing is multiplying by 1 here, and that is exactly what we're doing here. 5 over 2 root 3 times root 3 over root 3. We're just multiplying this expression by 1, so it doesn't change anything. Top isn't too bad. Top by top gives us 5 root 3 for the numerator. And the bottom, this is where we're going to remove the radical and rationalize the denominator. So the 2 is along for the ride because it's a coefficient. And we can multiply root 3 by root 3. When we do that, root 3 by root 3 is going to give us the square root of 9. And the square root of 9 is better known as 3. So this becomes 5 root 3 divided by 2 times 3, or finally 5 root 3 divided by 6. And there. So just like that, now we have a radical in the numerator, which is absolutely fine, but we've removed the radical from the denominator and have therefore rationalized it. The denominator is now a rational number. Alright, so now let's try a trickier one. This is with a monomial type denominator. Let's look at one where the denominator has 2 terms. Okay, so this is more of a binomial denominator. It's got a square root, and the way that we're going to get rid of this denominator, 4 minus root 6, is we're going to multiply by something called the conjugate. Now if this word hasn't come up for you before, it's not that complicated. Basically, if you have a pair of conjugates and you multiply them together, you get a difference of squares. So in the standard difference of squares setup, a minus b times a plus b gives you a squared minus b squared. This isn't quite a standard setup because we're involving square roots, but it's going to work the same. The square root of u plus the square root of v, its conjugate would be the square root of u minus the square root of v. So we multiply these together, we get the first term is going to be the square root of u squared, which is just going to simplify to u, right? Those two things will undo each other. The next term, if we multiply root v by u, is root v root u. And we could put that together and make it root vu, but there's not any benefit, as you're about to see, because we get on to the multiplying the both of the other terms by minus root v, so we get minus root v root u. So these two cross terms end up equaling 0, and they go away. And then last but not least, we're going to multiply root v by minus root v, and that gives us minus root v squared, which is just minus v. Okay, so it's a different setup, but it's still just a difference of squares. And these two things, root u plus root v and root u minus root v, are called the conjugates of each other. Okay, let's take a look at how it's going to go in practice down here, because here we've got a mix. We don't have 2 square roots. We've got 1 integer and we've got 1 radical. So the conjugate for 4 minus root 6 is just going to be 4 plus root 6. And if this had been 4 plus root 6, its conjugate would just have been 4 minus root 6. So again, we take our 5 root 3 over 4 minus the square root of 6. And we're going to multiply that by 1. This time 1 is going to look like the conjugate of this, which is going to be 4 plus root 6 divided by itself, 4 plus root 6. So this is the fancy way that we're going to write 1 now. You might find it helpful. I'm just going to put brackets around these binomial type terms because it just helps keep things separate. Yeah. Now let's do the numerator first, because the numerator is relatively straightforward. So we're going to have 5 root 3 times 4 plus root 6. We're going to use our distributive property here. The first term is going to be 5 root 3 times 4. So that's going to be 5 times 4, which is 20 root 3. The second term is going to be 5 root 3 times plus root 6. So that's going to be plus, the 5 has nobody to interact with because there's no coefficient. And the square root of 3 times the square root of 6 we can group together as the square root of 3 times 6, or the square root of 18. And that's it for the numerator, except for a little bit of simplifying. And actually we might as well do that little bit of simplifying now. 5 square root of 18, that's going to wind up being the square root of 18, remember, we can think of as the square root of 9 times 2. And the square root of 9 times 2, I can pull out that square root of 9 and write it as 3, so that is 3 root 2. So the last thing to do to this one is multiply 5 by 3 root 2, which is the square root of 18. 5 by 3 is 15. The first term doesn't change, so that's 20 root 3 plus 5, sorry, not 5, 5 times 3, which is 15 root 2. And that is it for our numerator. Okay, so now let's talk denominator. I'll show you the short way and then I'll show you the long way down here for the denominator. Since we've set this up, 4 minus root 6 times 4 plus root 6, we've set it up to be a difference of squares. I know the cross terms are going to disappear, so the first term is going to be 4 squared. And the second term is going to be minus root 6 squared. Okay. And root 6 squared, those two undo each other. So this is really just going to be 4 squared minus 6. 4 squared is 16 minus 6. All right. Now let's take a look at that a little bit longer, and I'll do that down here close to the bottom. So if I have 4 minus the square root of 16, and I multiply that by 4 plus the square root of 16, when I do these, I usually start with the front number and multiply it through the second bracket. There are other orders that people do these in that work. So, but 4 times 4 is going to give me 16. 4 times plus the square root of 16 is going to wind up being, and that's not 16, that's going to be 6. I was going to say square root of 16. Why would they do that? That's weird. That would just be 4. 4 minus root 6 and 4 plus root 6. All right, everything else I think is okay. All right, 4 times 4 is 16. 4 times root 6 is going to be plus 4 root 6. Now I'm going to move on to the minus root 6. Minus root 6 times 4 is going to be minus 4 root 6, and you can see where that's going to go to 0. And then last but not least, I've got minus root 6 times plus root 6, so that is going to be minus root 6 squared. And again, these two cross terms, 4 root 6 minus 4 root 6, go away because that equals 0. And we are left with 16 minus the square root of 6 squared, which is 6, and that is going to be better known as 10. Oops. All right. So we can simplify this a couple more steps. We're almost there. So I'm going to take this and I'm going to rewrite my numerator. So it's going to be 20 root 3 plus 15 root 2, all divided by, now it's 16 minus 6. So 16 minus 6 is just 10. Okay, and you might think you're done, and you're actually really, really close. The only thing left that we can do to simplify this is we can factor out each of these terms. The coefficients 20, 10, and 15 are all divisible by 5. So if you factor a 5 out of the top, you're going to get 5 times 4 root 3 plus 3 root 3. And if you factor a 5 out of the bottom, you're going to get 5 times 2. Okay, so 5 divided by 5 is 1, and those will go away, and we're left with our simplest form, which is just 4 root 3. And I have no idea why I seem to want, this is like the third time I've done this video, but trying to get it right. This is not a root 3, this is 5 root 2. There we go. Okay, but factoring, this is 3 root 2. 3 root 2, because I factored a 5 out of 15 and that left me with 3. I factored a 5 out of 20 and that left me with 4. And I factored a 5 out of 10 and that left me with 2. All right, I think life is good now, ish. Okay, so again, the 5 and 5 will divide out. That just makes 1, so those go away. And our simplest form is 4 root 3 plus 3 root 2, all divided by 2. Okay. The only other thing you could really do with that if you wanted to is separate it and write it 4 divided by 2 would be 2. So you could, if you really, really wanted to, you could write this as 2 root 3 plus 3 root 2 over 2. But I think stopping here probably is fine, just to leave it as a single expression. But this is also correct. All right, I hope that was useful. I've got one more video for this section to do, and it's going to be on dividing, just straight dividing rationals. But a lot of dividing rationals, radicals, sorry, not rationals. A lot of dividing radicals is going to be rationalizing our denominator. All right, thank you very much.